Assalamu alaikum. Hello everyone. I hope you're doing great. Today we're gonna cover resistors. So what you will learn, what is a resistor, what is a potentiometer, to read a resistor color code, understand the relationship between current, voltage, and resistor, and finally build a circuit using breadboard. So the list of material you're gonna need: an LED light emitting diode, a resistor, range from 220 to 1000 ohms, any value should be fine, potentiometer, jumper wires, breadboard, or if you don't have this equipment, those components here, you can always use your Tinkercad to simulate the project. So what is a resistor? A good definition: it's a component that basically block or make it difficult for the current to flow. So it's an opposition to the flow of current. That's what a resistor is. Okay. The fact that the wire become very hot is an evidence of there is some resistance. The conductor, on other hands, there is a little of resistance, like copper is type of conductors. On the other hand, the insulators have a large amount of resistance, just like, for example, plastic is a good type of ceramic also is a good type of insulators. So really inside of the resistor, we have on both ends nothing but the connecting lead or leads, and then here the material that is kind of covering the core of a resistor is insulating material and some coating material there. And then inside, this is one type of resistor which is made of carbon mixture. This type of carbon mixture or carbon film make it really difficult for the current to flow. Okay, some resistors have some type of coating, but anyway, the resistor, it just make it hard for the current to flow. Okay, that's what is a resistor. We don't get into details. So a resistor, this is just one type of resistor. There is this one is through hole resistor. So let's just take this resistor. See, the symbol we'll be using for designing a diagram, for creating a diagram, is this zigzag symbol here, and the letter R that represents the resistor. Unit is ohm. Okay, it's represented by this a Greek letter called omega. It looks like a shoe horse. So potentiometer, this is just an example. It's basically a potentiometer is nothing but a variable. Think about it as a variable resistor, and inside is a mechanical component that make the resistor bigger or larger. You can actually reduce or increase the resistor. Okay, so for example, the unit is it's still a resistor, so it's always ohms. So for example, if we turn this knob here of this potentiometer, we can go from, let's say, from value 300 to 400. If we keep turning, we might get other values. This is just simulation of what a potentiometer can do. A battery, we're going to be using this all kind of batteries, and the one we're going to be using this project is a 9-volt battery. This is the symbol of a battery. It has a positive side and negative side, and with letter V for volts. So the unit is volts. Just want to give you this picture, like be careful of touching anything that has a high current rating. The project we do, it's only 5 volts, and so the currents are really in milliamperes, very small, so it's we should be fine there. Symbol, this is one of the symbols represented by an arrow and a circle, and we use the letter I for currents, and the unit is ampere. So let's draw a circle So we're going to need the voltage or a battery, a resistor, and a switch to create some kind of circuit. So there are two types of circuits. When there is an opening in the circuit, so it's not circular, it doesn't complete the circle, it's called open circuits. And if, let's say, we close that switch, now we have a closed circuit. So when we close circuits and we have some voltage here, we're going to have a current. This is a conventional current. It goes from positive to negative, so it flows like this, okay? But actually what's happening, electrons are moving from negative edge of the battery to the positive edge of the battery, so it's flowing the other way, okay? So let's say we have a 9-volt battery, and let's say we have 1 amp, and we want to know what is the resistor that we can use in this circuit. So to be able to determine this resistor, we go to Mr. Ohm's law. So there is an Ohm's law that gives you the formula V voltage equal I ampere times R, which is ohm. So, and the other, if you want to, for example, calculate I, is nothing but voltage divided by resistance. And if you want to calculate, for example, resistance, is nothing but V divided by I. So this is just a funny cartoon or caricature showing Mr. Volt is pushing so hard on Mr. Ampere to go through that bottleneck, but Mr. Ohm is squeezing so he can't go through. So this is some kind of voltage Ampere Ohm relationship. This is a resistor this is just an example of a resistor that has 4 bands, and sometimes from the band you want to know what is the value of resistor. So from this color that you have here, we're going to use a color chart just like that. So for example, the color, the first band here, we have orange here, that give you the first digits. So we know this is orange, then orange is number 3, we put number 3 here. The second band, which is that give you the second digit, and we have white, so white is number 9, so we put number 9 here, okay? And then the third band, that give you a multiplier. So we have orange here, and orange basically, so we have orange here. Orange is 10K, so we have to multiply 39 by 10K, which is 390 kilo ohms. So that's what we get, okay? We get 390 kilo ohms using this, this third band here. The fourth band, that gives you some kind of tolerance, okay? Which is like really how accurate. So for example, silver, and silver is plus or minus 10% of this value can be added here. So it's 390 plus or minus the 10% of this value. This is how you calculate actually the resistance amount of any 4-band resistor. Now I want you to follow these steps to create with me this project, okay? So just what you're gonna need is an LED, light emitting diode, a resistor, a battery, and a breadboard, and then of course a bunch of wires for connecting ground and the positive side. So just follow these steps. Make sure that basically you get all these components from your toolbox, and make sure you you note how I'm connecting things. Follow step by step here, and we're gonna do it in Tinkercad. Now let's put a resistor. So we're gonna put a resistor here, okay? And the value of the resistor, 1000 ohm, that's fine. We don't have to change that. Let's see, do a simulation. We start our simulation. Notes that the light is turned on of the LED with no problem. I'm gonna stop the simulation. Now let's change the value of the resistor there. So let's say that change the value of this resistor right there. So instead of putting 1K, let's put, for example, 20 ohms. See what's going to happen. Start simulation. Oh, what happened here? We blew up the LED. A reason now we don't have 1K ohm resistor, we have only 20. So what happened? So we have to make sure the resistor is big enough to limit the current flowing. And remember, the current flowing of an LED is very small. So let's see how actually we can calculate this resistor here. Okay, I'm gonna stop the simulation, and then so the LED have a rating of 1.7 volts voltage drop on an LED, and a current rating 20 milliamp. Only that's the maximum rating. We shouldn't have more than 20 milliamp. So really, to find a good resistor for this project, we have to use the Ohm's law, this formula here, okay, which is R equal V divided by I, okay, and then plug these numbers. Let's see how actually that's done. Okay, so now let's calculate what is this resistor value here. So down here we have the 9-volt battery. Okay, so we have 9-volt battery. We're looking for this resistor value that will limit current going through an LED. So the symbol of an LED is like that, with some light going up. So this is our LED here. Remember, we mentioned that there is a 1.7 volt drop here, okay? So current flowing from the positive side, as I mentioned. So there is some current I, and we shouldn't be more than 20 milliampere, okay? Now using Ohm's law, what Ohm says, V equal I times R. To get R, we have to divide V by I, okay? And then if we place these values, V is 9 volts because there's a 1.7 volt. So we're going to do 9 minus 1.7 volts. I is this 20 milliampere, so it will be 20 times milliampere. Milli is 10 to the power minus 3 ampere, okay? So this, it will give you 7.3 divided by 20, and then we take this up there to the power 3. So finally, your R is 0.365, if I'm not mistaken, times 10 to the power 3 ohm, okay? That would, a good resistor value, it should be 365 ohm. So this is the value that it was calculated and we should be using in our project. So this value is what we found here. So the 365 ohm, this is how actually it was calculated. Okay, so we're gonna connect the terminal 1 here, and then the wiper of the potentiometer to the anode. Okay, so we're gonna do it like this instead of that resistor, and then just make sure that we're using the same range we were talking about, which is 1000 ohm. Right there, just make sure you change from kilo ohms to ohm here, okay? And then try to run this simulation. Oh, we blew it up, because here, remember, this is a variable resistor, and the value we have here, it's really a minimum. It's like 0 ohm, okay? So I'm gonna go now and try to increase this value. It's still too small, and it's saying the current through the LED is 37.3 milliamp. So it's really, you know, it's not, it's higher than its rating, which is 20 milliamp. Okay, so we're gonna continue increasing until that value is gone. So we should be fine. So that the optimal value, that's what we did in the exercise.